Hello everyone, I'm Sebastian Y and this is Foundations of Economics. In this video, I'm going to talk about two simple oligopoly models that we can use our basic game theory tools to analyze. The key assumption within oligopoly models is whether firms choose quantities or choose prices. In our study of simpler market structures, we have not had to make this distinction. In perfect competition, firms are price takers, so quantity choice is the only choice available to them. To keep things consistent with perfect competition, I always presented monopoly as a quantity setting problem, but in reality it doesn't really matter. We can have monopolies choose quantities or prices, and we end up getting the exact same answer, because the monopolist is simply choosing where along the demand curve they want to be. In oligopolies, this distinction does make a big difference. I'm going to use examples to illustrate the differences between price setting and quantity setting oligopolies, but in both I'm going to use the same demand function, which I'm going to write out using a schedule, where we have price and quantity demanded, and we have prices of $4, $5, and $6, with quantity demanded of 80, 70, and 60. I'm further going to assume that all firms in the market have a marginal cost of 0, and so firms will maximize profit by maximizing revenue. Note that marginal cost does not have to be 0 in an oligopoly. I'm just using this as a simplifying assumption. If we have a marginal cost, we need to take that into account when we're calculating profit. Finally, I'm going to assume that a monopoly, were they operating in this market, would choose a price of 6 and a quantity of 60 for a total profit of 360. As with the prisoner's dilemma, I'm going to use a normal form game matrix to illustrate what happens in this oligopoly model. We're going to have two firms, firm 1 and firm 2, and they have two possible options. They can choose to price at the monopoly price of $6, or they can attempt to undercut each other and charge $4. In reality, of course, firms could charge all kinds of different prices, but for simplicity, we're just going to boil this down to two options: monopoly price or attempt to undercut. We will also assume that firms make their decisions on their price simultaneously without any kind of communication with each other. The rules of this market are, if both firms charge the same price, then they split the demand equally. But if one firm charges below the other, then they take the entire market at that lower price. And so we have four possible outcomes of our four different combinations of prices. If I go ahead and add a profit column to our chart here, we can see that the total profit made at each of these prices would be 4 times 80, which is 320. At a price of 5, we have a total profit of 5 times 70, which is 350. And at a price of 6, we have 6 times 60 is 360. If both firms price at 4, they're going to split the quantity of 80, and so they're each going to sell 40 at a price of 4, and so they're each going to get 160, which of course is half of the 320 total profit. If both price at 6, then they're going to split the profit of 360 in half. They're both going to get 180. Now looking at the off diagonals, if firm 1 prices at 6 and firm 2 chooses 4, firm 2 successfully undercuts firm 1 and takes the entire market at that price of $4, and so they're going to get the 320 all to themselves. Firm 1 will get 0. In the final box, we have the reverse of this, where firm 1 undercuts firm 2 and gets 320, leaving firm 2 with nothing. Looking at these payoffs, we can see that firm 1 always does better by choosing $4. 160 is better than 0, 320 is better than 180, and so no matter what firm 2 does, firm 1 should pick $4. Firm 2 has the exact same situation. 160 is better than 0, and 320 is better than 180, and so they're always better off picking $4. And so for each firm, trying to undercut rather than trying to cooperate is always the way that they individually maximize profit. So in our Nash equilibrium, both firms choose $4 and make a profit of 160. Just like in the prisoner's dilemma, both firms would have been better off had they been able to cooperate and each set the monopoly price of $6. They would have both made 180 instead of 160. But because of their own individual greed, they try to undercut each other and they end up with less profit. We're now going to think about the quantity setting version of this model. We are again going to draw a normal form game matrix to represent this game. We're still going to have two options, but this time firms are choosing quantities instead of prices. The rules of this game are that each firm chooses their quantities simultaneously with no communication. Once they choose their output, we use the demand schedule to figure out what the price is going to be and then determine the profit that each firm makes. The price adjusts so that all units are sold. Remember that our monopoly outcome is a price of 6 and a quantity of 60. We're going to give two choices of quantities to our firms. They can choose to cooperate with each other and produce half of the monopoly output, so 30 units, or they could choose to produce more than that and go up to a production level of 40. We can now use our demand schedule to figure out the profit that each firm makes. If each firm produces 40, we have a total quantity in the market of 80 and a price of 4, and so each firm is going to make 4 times 40 profit, or half of the 320, if you prefer that way. So each firm is going to make 160 profit. Similarly, if each firm produces 30, we're going to have 60 total output and a price of 6, and so each firm is going to make 6 times 30, or 180 profit. These two boxes are exactly the same as over in the price setting version. The off diagonals do look a little bit different. If firm 1 produces 30 and firm 2 produces 40, we have a total of 70 output, and so our price is 5. If firm 1 produced 30 units, 30 times 5 is 150, and if firm 2 produced 40, 40 times 5 is 200. It looks very similar in the upper right box, where the total quantity is still 70 and the price is 5, but here firm 1 produces 40, and so they get 200 profit, and firm 2 produces 30, and so they get 150 profit. We can do the exact same analysis as we did in our previous games. Firm 1 always does better by producing 40. 160 is better than 150, 200 is better than 180. Firm 2 faces the exact same thing. 160 is better than 150, and 200 is better than 180, and so we always are going to end up with both firms producing 40 units of output. That gives them each a profit of 160, just like they did over in the price setting version. We get the same result here as in the classic Prisoner's Dilemma and the pricing game. Firms would have been better off had they been able to agree to behave like a monopoly, and each restrict their output to 30 units in order to raise the price up to 6. But they fail to do that because of their own self-interest. They always have an incentive to overproduce, and they end up in the upper left corner, which is our Nash equilibrium of both firms producing 40 and getting a profit of 160. Although both of these models have a similar outcome in that we end up not cooperating when cooperation would have been better, the details are a little different, and we see those differences in the off-diagonal boxes. Here in the quantity setting game, the only thing that a firm can do to cheat on the potential cooperative agreement is to overproduce. They can't steal any sales from the other firm. The other firm is still producing 30 and making an okay profit of 150. It's lower than all the other profits, but it's better than nothing, which is what they get in the price setting game if they get defected on. In the price setting game, getting undercut on is disastrous because they end up getting 0 profit, while the other firm ends up with a huge profit of 320. And so even if firms are able to communicate, there's still a huge temptation to cheat on any kind of cooperative agreement that they come to, particularly in the price setting game. The last thing I want to point out here is that the two models that I've shown, the price setting and the quantity setting games, are simplified versions of the Bertrand model of oligopoly and the Cournot model of oligopoly. These are foundational cornerstone models in industrial organization and game theory in general. The full versions of these models are more complicated in that they allow firms to choose any price, not just two prices, or any quantity, not just two quantities, but the overall lessons remain the same. Firms are better off by cooperating, but they fail to do so in the Nash equilibrium because of their own self-interest. This has been a brief introduction to oligopoly models and game theory. If you have any questions, feel free to let me know. Thanks for watching.